Okay, so hello and welcome to today's panel discussion on supply chain security and counterfeit avoidance. Now, with the recent component shortages and supply chain disruption, there's been increased instances of counterfeits making their way into the supply chain. So we're going to discuss that today with this very eminent panel. I have to my extreme left there Gadi Meik. He is the Senior Director of Industry Strategy at Arch Systems. To his right here and next to me, we have Elliott, who's the Technical Marketing Manager for Siemens Mentor. And joining us remotely is our friend and colleague, Michael Ford from Aegis Corporation. So nice to see you, Michael. Thank you for joining us today. So I'm going to get right in with the first question, which I'll start with you, Gadi, if I may. And that is, what steps can we take to keep PCB designs secure before they go into production? Now, where I'm coming from with this particular question is that if you cast your mind back to the micro computer situation, we found out that the actual counterfeit was designed into the original design of the product. So the design was compromised. So how do we avoid that type of thing happening in the future?
So generally, we need to keep the design, eventually as much, the internal. When you need to approach, let's say, third party, you need to have embedded, tools and procedures that you are, have audit for verifying, that they have the right tools for security and it's not leakage to anyone. Mm-hmm. So mainly to maintain, as much as possible, the design in-house. Even trying, we are talking about Industry 4. Even, if you have the ability to do the 3D printing or whatever, additive manufacturing for the PCB, even it's another option, to try to keep it in-house and not to expose it to too many people. Exposing eventually, you need to control them.
Right.
You're not, for third party especially. So that will be the approach. Try to keep as much as you can, in-house.
Right.
If you need, verify, that you have the right procedures to verify that it's not leakage.
Right. So keep as much in-house and maybe avoid using external agencies to work on the design. Yeah. Would you concur with that, Zach?
Yeah, I mean, I think a lot of the tier ones, the big manufacturers, have tools to collaborate with their supply chain. They have, secure tools that keep their intellectual property secured for them. So I think but that leaves the rest of us, that don't have these tools. So I think, to Gadi's point, keeping things in-house is great. And when you need to share with your supply chain, you need to have secure collaborative platforms to do that, so you don't have leakage and problems. Yeah.
Okay, Michael, you got any input on that? I remember it was you that actually told me the first about that Supermicro story. So, anything to add to what we've discussed already?
Yeah, sure. I mean, it's important to maintain security at the design level, even if working with an ODM, for example, where you're collaborating. Make sure that the design side of the ODM is completely separate from the manufacturing side. And kind of to address that gap, it's good to use a file format to transfer the design data which does not reveal the IP of the product. So never send raw data files, and people do, it's surprising. So instead use a format like the IPC 2581, which is a format that explains the need to know items of the design for manufacturing. ODB++ is another intelligent format. The advantage is that in these single files, they're much easier to secure. Now we've been working out a way of how can we transfer the data from design into manufacturing without, for example, using insecure mechanisms like email or various different messaging methods. And so we've come up with a method using CFX, which encrypts the data over the internet to be able to, first of all, maybe share the 2581 file, but in extreme cases where, you really want to protect that IP, to only make certain parts of the data accessible to those on a need-to-know basis. So, for example, setting up a specific machine, they only need to see the information relevant to that machine setup. to make programs for a line of machines, you only need to see a certain amount of data again. So we're working on this methodology that provides this secure platform where if you want to share, then it will be secure. Whereas if you don't want to share, there is then an ultra secure way of accessing the data that you need only when you need it.
Yeah, that's very, very helpful. I mean, I think it's important that we need to guide the industry through standards to be able to tighten down on the security. One area that's been very lax, as we know, is consumer products. Consumer products have got very little security in them, but I mean, it's so easy for people to hack into your fridge or your Zoom, your Roomba or something like that. Is there a requirement then to put a standard in place for consumer products, to say that they have to have a certain level of security, to make them more reliable? Who wants to take that first? Gadi?
So eventually, I believe that eventually your data is secure, as like Michael was saying, by actually the tool you're using. So that's the level of security. As much as you have your embedded, tool that is secure level per users, and so you are actually managing that. It's not opening. Again, for me, it's important if you are using a third party, like NDA, right? The right NDA that you are assured, that it's not, you have, the permission to pass it over. And auditing, you have special audit, standard audit to go through the security of the third party to see that they have the system embedded, that they have password and users. So also to know that what you are passing, they have security level enough to maintain.
Right. Okay. Zach, what's the Siemens view on consumer products and that and security at that level?
Yeah, well, I mean, we talked about it before that we're sending designs through email, and my phone has my email, and my phone connects to the refrigerator, and the refrigerator is not secure. So, there's all these ways that we're opening ourselves up that we haven't even really, I think, considered yet. So, of course, we support standards. We think it gives everyone, a level playing field, a common understanding of the risk involved with what we're doing. So I think at Siemens, we completely support standards in that respect.
Okay, great. So Michael, back to you. Obviously, you've been involved in many standards. Do you think there's one required for consumer level products?
It's getting there, yeah, for sure. Because as Zach just said, everything is connected. Your car is connected to your phone, is connected to your PC, all connected through the internet. And, there are a lot of people out there. There are lots of YouTube videos you can look at where cars are taken over and driven remotely and driven into a ditch. There's a great one about that. And we're taking our life into our own hands, if we're driving around in things that are insecure or, even things around the house that can, make some catastrophic damage if we leave it unchecked. And so what we're kind of looking at is a standard for creating a fingerprint for every device that you would have in your house. And that fingerprint is created through the manufacturing process, such that if anything untoward happens to that product at any time, that fingerprint can be then checked and confirmed against the original. So this, of course, is made up throughout manufacturing based on fingerprints of individual components. For example, the critical semiconductors. They will have a unique ID that's burned into them at birth. And then as they're associated with the product, all of their fingerprints combine onto a circuit board into a controller into a final product. So, of course, there needs to be a standard because we need interoperability between the semiconductor area, the assembly, and, of course, all of the different verticals and product types that are out there. But what it means is that you can get into your car, press the start button, and at that point, it will then confirm that digital ID of that product and then say that it's safe for use. It has not been hacked in any way. And of course, cars do go in for servicing. We see a lot of problems coming in the servicing of cars, aircraft, even military hardware. That's where the problems start to happen. So it has to be a continuous process. So yes, I think starting at the top end, then gradually drifting down, we are going to see, because things are connected, that we have to have this level of digital fingerprint identity to make sure the provenance of our products that we trust is retained.
Well, I understand what you're saying, and I think it's a great suggestion and way forward. It relies, of course, on some of these companies coming up with the technology to be able to embed these fingerprints onto these devices securely. And I know
Yeah,
there's a
we
couple
are
of
seeing
different approaches to that.
we're seeing groups, even starting from semiconductor, that are really starting to talk seriously about this and are looking for the way forward. So it's yet to be completely organized, I would say, putting the standards together with the group that's driving the interest in this. But it's happening. It's on the horizon.
Okay, so let's bring it back to the manufacturing line for a minute. Zach, I mean, what do you think is the optimal counterfeit verification system, an alert that could be built into the manufacturing line?
Yeah, something that I've seen recently, I think it's a really kind of novel new use of AI is actually using all of the images that come from the SMT machines as they're looking at the components before they place them to align them.
Mm-hmm.
And you can actually have an AI model that can detect counterfeit components, can detect when something in that lot doesn't match the rest of it or doesn't match the kind of digital fingerprint for that component. So that's a really interesting way to do it. It stops it at the line. It doesn't allow that component to be assembled. And if something escaped all of the other controls that are in place, it's kind of, the last place to stop it. So I think that's a really interesting kind of novel approach, kind of innovative, cutting edge kind of looking at how to prevent counterfeit.
Okay. And what about at Arch? Do you have something similar? That
Actually, I'm supporting, I know the system of trying to actually monitor during placement,
Mm-hmm.
the counterfeit component. And besides, the counterfeit component, you're be able also to look, if there is hack on the component itself, and it trace, for probes in the component itself, so that there is no malware installed to avoid, cyber attacks on that point. So this is an online alerting system that for me it's great. I think that another level that we should put in that is, we are working shortage right now in components,
Mm-hmm.
and you are forced to work with more brokers, and that's a risk. And that will be also embedded, during the incoming inspection. Right now it's manually, so try to automate that with the same maybe principle of trying to visualize incoming inspection before production even.
Right. So when you're working with you're working with brokers. You're not working directly with the component manufacturers, because there's a number of systems coming out there that are, embedding APIs into the manufacturers' factories, so you get a more real-time vision of what the availability is and the current pricing even.
Yeah, eventually, you have, the AVL that you are, but because of shortage, you compromise.
Yeah.
You compromise, and then you are working, but then you have to need to have, like we were saying, a tool or a certain level of verification, even traceability for if something happened to do surgical analysis on what the product was having.
Right. Okay.
Yeah, and I think you make a good point that it's not really just fake counterfeit components we're looking for. It's these reused components that have been tampered with, and mixed lots. You mentioned traceability, so if you go to a broker and they've mixed two lots on a reel and you don't know it, your traceability is blown out, and you don't have that ability to go back and find out what happened. So
actually, you were talking about AI. I think that it's need to provide us an extra glasses that we were not seeing until now. We were relying maybe on the AOI, something that maybe, so we need another level to.
You need another level of inspection,
Exactly.
to be able to.
Exactly. To be able to deal, with counterfeit components, and first of all, bring it to the awareness of production,
Mm-hmm.
that there is such a thing, because production is about quantity and quality of So bring it first of all to that level and providing AI tool, to support that.
That's interesting. That's the first time I've heard that suggestion. But that brings me into my next question, really, which is what counterfeit threats have emerged during the pandemic. Michael, do you want to chip in on that?
Yeah, sure. I mean, we've been basically exploding the situation as people are turning to extraordinary suppliers of components. And, often, I'll agree with what was just mentioned about the incoming inspection, heightened inspection in certain cases, and also the automated technologies now are amazing. They're doing a great job. It's just so sad to me that we have to do all of this because it adds cost and time to the manufacturing operation. I mean, we've had years now where we've been able to trust suppliers to deliver good materials, and we've seen the benefits of that in terms of reduced costs. So there has to be something else that we can do to prevent counterfeits, not just detect them and then through the use of traceability, maybe feed it back. I mean, that's a good start, but we need to feed that back all the way up to the point of ingress. Because what we've been seeing over the pandemic period is that a lot of people have stockpiled and then they've seen time go on. The products have maybe gone to end of life, or at least the new generations coming in, a lot of obsolete parts on the shelves. They're degrading. People want to sell them back into the market, perhaps make a profit. Why not? Sell it for 10 times the amount that you paid for it. But how do you then guarantee that that material is as good as when it was first received? So you need to understand about the manufacturer or the holder of that material. What were the conditions in the warehouse? Are they reputable? Are they to be trusted? Has material been part used? So there are a lot of different questions now that are beginning to be asked, things that were maybe unthinkable before, where we would use materials from the grey market. And we have to modify how we work. So we have to start to keep track, keep records, keep traceability, make it available in a way that doesn't, compromise our privacy. And so this is all about building a more interoperable supply chain that deals with these, sudden increases in shortages, and that gives incentive for, let's call them the bad guys, to introduce counterfeit materials, which they're quite capable of doing.
Right. Well, one of the areas that you were talking about, or we've talked about before, is smart packaging. Being able to have make sure that the packaging is anti-tamper proof from the point that it leaves the component manufacturer to the point of delivery to the factory, and being able to check all the touch points along that supply chain route. You think, is that something that's going to become reality?
Yeah, absolutely. The IPC 1782A Secure Supply Chain and Traceability Standard was adopted by the DoD last year. And this shows the methodology of how to package components, how to then deal with those packages anonymously with tamper-evident packaging, labeling, the use of blockchain to then make sure that the records associated with the packages are not tampered with. And so following this process ensures a very simple thing, that what you put into the box at the beginning is what you get out at the end. Right. Very, very simple thing. But, throughout all of that process is where you get the danger of people intercepting the materials, replacing them with something that you're not sure about. So covering all of the processes, including distribution and mixing of components, is all included in 1782A.
Okay. Good.
I would like to remark, you were talking about the aging of the component, that we actually receive something that's supposed to be according to the standard, something, an age like 12 months or whatever, the standard is. We actually do not know the lifestyle, the life cycle that we receive. And this is something that, again, we are counting, okay. But if we could also embed, some AI also to actually realize that the aging that we are receiving is the right. That will be a game breaker, I believe, eventually, to know the age of the component itself.
I'm sure that type of information could be included on the barcoding that's on the packaging.
Yeah, but this is something that the barcode that's saying it's 12 months. But actually, like Michael was saying, it's actually 3 years ago. It was laying on the warehouse and put it inside. Yeah. So you need to verify that.
Right. Okay.
Yeah, exactly.
Zach, I mean, have you any systems for that you can think of it for helping to verify the supply chain for components?
Yeah, we have recently started working with some technology that looks into the supply chain, looks at the availability materials, and can give you information about the age and things like that. And that's really great, to have that information. But I think what the industry really needs is, it's the scary thing, we need to start sharing our information about when we run into counterfeits and the quality issues we're having with our materials, so that everyone can benefit from one person having a problem. So that's really going to be the hard part, to share that information, to keep your own intellectual property private. And I think that's going to be the big challenge. But it's
so is that something that's going to have to be done by a trade association that can be seen to be agnostic and be able to keep that information secure, but alert you when there is a threat out there?
Yeah, I think there's it's kind of a cat and mouse game. I think you need innovative solutions that are looking at the challenges that are happening right now, and then you need standards to follow up to make that the standard accepted practice.
Yeah.
And especially with you look at security standards, those that are looking to exploit the system and to counterfeit and to they're going to take a standard and then they're immediately going to look, how do you exploit this? So it kind of becomes, to some degree, a blueprint to how people are working, and now you can look for holes and exploit that. So I believe you do need some innovative solutions that are kind of pushing the boundaries and a little maybe one step ahead of where the standards are going.
Okay. So, Gabby, have you got a take on this in terms of how do you secure the provenance of components in the supply chain?
Yeah, eventually, like Zach was mentioned, we are trying to actually it's detecting. So I completely agree with Michael. Detecting is good. So you actually trying to minimize leakage of something wrong in the line, and while it's not interfering in the cycle time that you are producing, that's okay. But it's still detecting. We need to think maybe outside the box how we go to preventing. And through standard, it could be a way, to make it more difficult for, to enter. But I agree with you. Eventually, they will find the way to overcome that. So it's a cat and mouse. Yeah, I agree with that definition, that we need to all the time do the interaction and try to think differently.
Okay. As I mentioned a little bit earlier in the panel, there's some companies using electronic systems to be able to embed APIs into the component suppliers' factories. What are the pros and cons of that approach? And I'll start with you, Zach, because you recently, or Siemens recently, bought a company who has that capability. So you've probably got first-hand knowledge of it. Right. What are the pros and cons of using that?
Yeah, I mean, I think it's the ultimate security, having it built into the chip. So that's a big pro. I think that's where we want to be. But it's just a long process to get there. As Michael mentioned, it takes changing of this semiconductor fab, and the whole supply chain has to kind of retool and gear up for that. And we have a lot of components that are out there sitting that need to be dealt with today. So I think the pro is the ideal place in the future, but there's a lot of steps that need to be taken to get there, and a lot of components that are already out there and that are still being produced that we have to deal with today.
Right.
Actually, it's come to the shortage of components. So you could have that, you compromise. I don't have anything, so you go to something that doesn't have that. So that would be...
Yeah. I think having accurate knowledge of where components are in the supply chain is fairly critical nowadays, because then even if you can't get a component, you at least got a very accurate trace of what you do have. So you can switch around your production schedule and say, well, we can't make that, but we can make this. So I think it's probably the way. Yeah. Any thoughts on that, Michael?
Yeah, it is interesting because we're kind of talking more about sharing data and all of these kind of things, but in reality, nobody wants to share data because they lose their privacy. And so one of the things that we can learn from COVID, or maybe COVID learned from us, I'm not sure, is how to keep data private. For example, you know, in many countries right now, there are like COVID passes where information about how you've been vaccinated, etc., are retained in a computer system somewhere. But you don't need to share that data with anybody. All you need to understand is, have I achieved the necessary level of vaccination to go to a trade show or to go to a concert or theater or something like that. So the concept of verifiable credentials is becoming extremely interesting. So that in electronics, instead of sharing all of the minute technical detail of traceability and having people work out, is this, you know, supply chain secure or not? Actually, we can create verifiable credentials that simply ask a question. Has this component come from a reputable source? Has this assembly been made with the proper tests, with the proper digital fingerprints, for example? And then, without having to share the detail of manufacturing, which people are reluctant to do because it exposes their IP, they can simply then get an answer back to say yes or no. And if it's no, they don't know why. They simply know that I'm not going to touch this component or this product, or something has been compromised. And then there are other people who will look into that, who are already accessing that data. So this concept of privacy, whilst sharing key facts related to manufacturing, is very, very important to break through this barrier, which is, how can I be smart and contribute to the security of the supply chain without compromising my business in terms of exposing things like, you know, capabilities, delivery dates, what I'm making, when I made it, how I made it, and all of those other good things. So I think this is an important turning point where we can start to work together on these verifiable credentials.
So basically, it's going to be on a need-to-know basis, essentially. But
Yes.
yeah, I do think that you software guys do have to learn to play together in the same sandbox, because you know, in this industry, the pick and place companies went through that at an early stage. You know, when Industry 4.0 first came around, what was happening was they started out saying, well, it has to be proprietary systems. You know, you have to work with our proprietary system, and there's no other alternative. But they very quickly found out that they would go into a factory and there'd be a mix of other machines in there, and the vendor wasn't, you know, the manufacturer wasn't going to start throwing his old machines out. So they had to learn to work with things. And the same has just happened more recently with the inspection boys, you know, the AOI and the SPI. They're learning that they have to talk to each other a bit more. So I think as it comes to pass, I think that the same will be true in the software space.
One remark regarding Michael mentioned, you know, about sharing an idea, you know, about if we, maybe not to provide all the data because people want to protect, you know, their.
Mhm.
But if we were able to share the internal scoring of what we have per supplier, let's say that I'm producing and I have a very low scoring about certain supplier that give me counterfeit, this maybe
that'd be a good
it
start.
will be shared, it will be a start, you know.
Absolutely, absolutely. Okay, unfortunately, guys, we're running right out of time. We are broadcasting live, so we have to stick to the schedule. But I want to thank everybody for taking part today. We have, of course, Gadi Meik from Arch Systems at the end, Zach Elliott from Siemens Mentor, and, of course, Michael Ford from Aegis Corporation. So thank you all for taking part, and thank you to our audience. Coming up after the break, we will be going on to our next panel discussion on sustainability on the factory floor.